Hello guys, Mr. G here and with another video for projectile or about projectile for the grade 12. This time we're going to be practicing what we done last time, which is equation of motions, and we are going to be doing two questions, okay? One of them is not so bad, but the second one may be a little bit tricky. Next time we're still going to do two more questions before we're going to graphs. We must make sure you understand and be able to do different questions, and later on we'll do more of the graphs again. Okay, now let's start with the first question. This question is saying a boy stands on a bridge 50 meters high over the river. He throws a stone vertically upward over the edge of the bridge with a speed of 5 meters per second. Know the effect of friction. 1.1 calculate how long the stone is in the air. 1.2 calculate the maximum height the stone reaches, and 1.3 calculate the time taken by the stone to reach its maximum height. This question is not so bad, so we're going to do it. But before we move on, the first thing we're going to do is to have an idea of what is going on, and we are going to do that one by a small sketch or drawing. So we have here, let's say this is the bridge. This is the bridge, and then at the bottom is the river. So here somewhere you have a river. This is the river, and that one is the bridge. And somebody throw a stone vertically upward from the bridge, and obviously that stone is going to move all the way up and then it's coming down to the bridge, but that is not the part right now. Okay, now what we need to know is that the bridge is 30 meters high. The height from here to there is 30 meters. That is important, and you must know that when the stone reaches the river, the displacement the stone has covered is from the bridge to the river. So this one here will be the displacement of the stone, which is 30 meters. Okay, now remember, because we are talking about vectors, that must be either positive or negative. So for this question, let's say, for example, up is positive, or rather let's write down is positive. Now if down is positive, this displacement we were speaking about, this one here, is going to be then positive because it's also a down. Let's fix this one to make it understandable. There we go, the plus, that is positive there. Okay, now what other data we have here? The stone was thrown with a speed of 5 meters per second, so the magnitude of the velocity was 5 meters per second. Let's write that data as well. The initial velocity of the object was equal to 5 meters per second, but it was thrown up, so down is positive, therefore up is negative, and it's a -5. Please guys, this is really important. Okay, and now what other data we have here, even though they don't tell us? The acceleration due to gravity. The acceleration due to gravity, which is equal to 9.8 meters per second square, it is down, and therefore it is positive. Now all these directions are very important, so please make sure you write the direction you take as positive, and then you will be able to understand and not make mistake when you substitute the values. Okay, so let's answer question 1.1. calculate how long the stone is in the air. Now to calculate how long, there are different methods to calculate these questions, and I can really not answer all of them. You can try other ways. Whatever you see first in the question, try it, and maybe you get the answer. But what I'm going to do is to use a formula that has all the data that we have here. In this case is the data, the formula of displacement. We say that, I'm going back to momentum. The displacement is equal to initial velocity multiplied by 10 plus half the acceleration due to gravity multiplied by time to the power 2. So if we notice, we have all the data, and this time that is here, this time here is the total time. Okay, now you will say, Mr. G is going again to quadratic equation. No, but remember, you have calculators, guys. Nothing is really that difficult here. It's not big things of substitute numbers, but let's substitute the numbers and remember the symbol, the signs of those substitutions, okay? Okay, and now you will get two answers. Now, if you substitute the minus, you will get a negative answer. So, if you substitute the minus, you don't have to write this one, okay? The answer will be equal to negative 2,02 seconds. But we cannot have a negative answer for time. So this is already wrong. And the other answer, when you substitute a positive, is going to be equal to 3,04 seconds. Please check the calculation and let me know. Let me know if there is a mistake. I hope there is none. But sometimes the calculations are tricky when you are making a video. So that is the first question. That was question 1.1. So question 1.2. Say calculate the maximum height the stone reaches. Now the maximum height the stone reaches, né? So as from when it was thrown. So now we have the same data, but we also have the time. But the time, this one is not relevant because it's the time from beginning to final, and we don't want that. We want to know how far did stone move up from the bridge. That is the question. So in actual fact, they want to know here, this is the maximum height from the point of release. This is what they want to know. How high is that point then? Okay, so for that point we have different data, of course. So this one is question 1.2. So let's write the relevant data for that point quickly. Data for that point. The initial speed, and we're going to keep the direction down as positive, even though it may be more uncountable because now we have in the object moving up, but it's fine. So what data we have? Initial velocity is going to be negative because we say down is positive, and this one stays as 5. Okay, so it's 5 meters per second. That is the initial velocity. What else do we know? We know that the final velocity, which is at the maximum height, is equal to 0. This one is at maximum height. That is y is equal to 0. Okay? We know the acceleration due to gravity is equal to positive 9.8 meters per second square. Positive because we said down is positive there. If we didn't say it, then it would be negative, of course. Okay, and we are looking for the maximum height, which in this case, as is moving up, or as it move up, is going to be equal to the displacement. Okay, so this is what we have now. According to this one, the best formula to use is the one that says that the final velocity square is equal to the initial velocity square plus acceleration, or plus 2 times the acceleration multiplied by the displacement. Now the displacement here is equivalent to the maximum height as it moves up. Okay, so if you substitute okay, so I hope you understand. This one is not that bad. Okay, and then it's only one question left, which is the time. Calculate the time the stone reached its maximum height. How long the stone took to arrive or to reach that maximum height. And then it is the same data. The only thing is we need to calculate a different thing, but it's quite easy. So 1.3 is the same data we have, right? Plus we have now the displacement upward. Remember, we took up as positive, as negative, down positive, and we're going to keep it like that for the entire question. Okay, so now here, but note that you don't have to do that. You can change the direction question by question if you want to. Okay, so now here we're going to keep the data. What formula can we use? Final velocity is equal to initial velocity plus acceleration multiplied by the time. We have the time, we have the acceleration, we have the final and the initial velocity to reach the maximum height. Okay, so it's the same data as in the previous question. So this is the time the stone took to reach its maximum height. Okay, so this is the first question. I hope you understand. I hope it's not that complicated. We're going to be doing another question and then this video will be ending. Now we are ready to do the second question. So this question 2 was a question in the trial examination from 2014. Now say a ball is projected vertically upward next to a building. The ball reaches a maximum height above the ground before moving downward. On its way down, it passes a window 2.2 meters high in the building in 0.2 seconds. Note, the length of the window is 2.2 meters. Alright, and the time it takes is 0.2 seconds. So let's quickly write that one. The time to go there, past that window from there to there, this distance here was 0.2 seconds. So let's do it like this, 0.2 seconds. The bottom of the window is 1.2 meters above the ground. Ignore the effect of a friction. Now this question may be a little bit tricky. However, let's write a few things here. This is the maximum height. That is the maximum height and is, we don't know the maximum height, but we know that the velocity d at that point is equal to 0. Okay, so let's see what else. Write down the acceleration of the ball at the maximum height. So if you go to the video we spoke about acceleration, which was the first video on a projectile, you could say that the acceleration due to gravity at any point is going to be 9.8 meters per second square downward. Now I prefer to say towards the center of the earth will be correct, but I'm not going to write it, it's too long, and you know we spoke about that a lot. Okay, so write down the acceleration of the ball. Now acceleration, as they said here, is a vector quantity, so they want both. They want magnitude and they want direction. Magnitude and direction, which is what we gave here. We said 9.8 meters per second square, that is the magnitude, downward is the direction. Second mark, write down the magnitude of the velocity of the ball at the maximum height. So at the maximum height, the magnitude of the velocity is 0, and we did write it here as well. We said that the velocity at the maximum height is 0. Okay, so that is the first two questions, very important, no calculation required. Calculate the velocity of the ball at the top of the window. So they want to know what is the velocity of the ball at the top of the window when the object is right there. Now, not the following, that is the velocity, okay, of the object. That is what they want. Remember when we learn about magnitude of the velocity. So the velocity of that ball is the same when it's going up, that is the velocity, I'm going to write up, is going to be equal in magnitude to the velocity down. Velocity down. So that is an important point. The velocity at that specific point there is going to be the same. Okay, so that is important. So what side we are going to work here? We are going to work with the part as from the top of the window to the ground, because it's the only part where we have some data. So for that problem, we are going to take only the window. So when the object is moving down, but we are going to take only the window. That is the part we are going to be working there. All right. So now for that window, let's see what we have. Let's say this here is the window. Okay. Now we know this is just the window, okay? Now we say, remember, as it moves down. As it moves down. So we're going to take only the part when the ball is moving from top of the window down. Remember, it's the same as moving up and down. So we know that the length of the window is equal to 2,2 meters. This is given to us. We know that the time from top of the window to down here, the time was 0,2 seconds. All right, we are looking for the velocity at this point there. That velocity is going to be unknown, that is the question mark. So we are going to say down is positive. And from here, what data we have? Well, we have all that apart from the acceleration due to gravity, which we don't know. So what formula can we use? The displacement, which in this case is the length of the window, as the object is moving down, or this one will be the displacement, is equal to the initial velocity, which is what we are actually looking for, multiplied by the time plus half the acceleration due to gravity multiplied by the time to the power 2. And this formula have all the information we need. So we can now substitute. And that is how we calculate the initial velocity, or the velocity of the ball right at the top of the window. Question 2.4. Use equation of motion to calculate the initial speed of the ball. Now, the same story. Now we are going to work from the ground to top of the window because we have all the information. So let's redraw here quickly what I'm talking about. This is the ground. The window is somewhere there. Right? This distance is given to us, which is 1,2 meters. We have this distance, which is 2,2 meters. We have also that the velocity at this point is going to be equal to 10,02 meters per second. So it is the same when it's going up and when it's going down. So I'm going to just write the magnitude there. So having in mind what we have for this part of the problem, we're going to say up positive, and as it moves up. So we're going to work when the object is moving up, and when the object is moving up, the displacement is going to be from the ground to that point on top of the window. That is the displacement, and is equal to the addition of 2,2 and 1,2 meters. All right, so if we have that one, the final velocity is going to be the top of the window, and in this case the initial velocity will be the velocity with which the ball was thrown, which we don't know. Now, what formula is most suitable for this one? We can say that the final velocity square is equal to the initial velocity square plus 2 times acceleration multiplied by the displacement. Alright, we're looking for the initial velocity in this case here, and when we do the substitution, and that is the answer, because they're asking you for the speed. The speed doesn't have direction, it's only magnitude, and that is the final answer, but it's quite simple. Okay, so now this one here is question 2.4. We didn't write the question we are doing, and this one is question 2.3. okay, so those are the answers. And the final question here that we're going to do, say calculate the time the ball takes to reach its maximum height above the ground. Now, once more, remember each of these questions have many ways to be solved. But the simplest one I found is 3.5. Is to use from ground level. I don't need a window, so I'm not going to even draw the window, to the top, to the maximum height. This is height maximum. Let's write the h first. This is the maximum height. Okay, because we have all the data. We have the initial velocity, which was just calculated and is 12.92 meters per second. We have the final velocity here, which is 0 because it's at the maximum height, and the time is what we are looking for. So, and the acceleration is down to 9.8. So we're going to take here a positive downward, and we are going to write it down positive. Remember, in this question, one sub question could be down up positive, and in the other one can be up positive. It doesn't really matter. So if down is positive, that means that the final velocity is equal to the initial velocity plus acceleration multiplied by the time. And when you substitute, and guys, this is all for now. Okay, so thank you for watching. As usual, subscribe for the channel, ask questions. I hope it helped. This specific question is a little bit more tricky. Next video we're going to be doing 2 more questions before we go to graph. But thank you for watching. I hope you understand. I hope it can help you. Thumb up, subscribe. I'll see you next time. Mr. G here.